Okay, so we're going to continue on this topic of half angles, and this one is an example of doing a solving a trig equation using a half angle. Okay, so notice you have a half angle of sine, right? And you have cosine, and then you have 1. And so really what you want to do is just substitute your sine half angle formula into this expression. So why don't you do that? So you're going to have plus or minus the square root of 1 minus cosine x all over 2, right, plus cosine of x is equal to 1. Okay, so at this point, everything's in terms of cosine, right? And this is really just solving a radical equation. And if you remember, in a radical equation, or even in a trig function, if you have two trig functions, what you want to do, and a non-zero constant, you want to isolate one of those trig functions and then start squaring both sides, right? And so in this case, I want to isolate my radical, right? To get rid of it, I'm going to have to square both sides. But you don't want to start squaring right now. If you start squaring too early, right? If you start squaring this side, you're going to get something really, really messy. So why don't you move that cosine x over and then start squaring? Okay, so if I move it over, I'm going to get 1 minus cosine of x, right? And then from here, right, hopefully you can see, then you should start squaring, because this will completely get rid of the square root symbol. And then this one, you just have to FOIL a binomial. So let's do that. Okay, if I square root, right, it's going to get rid of the radical. If I square a negative number, it's going to be positive. I don't have to worry about plus or minus. I end up with something nice and clean. Okay, and this one right here, right, you have to know how to FOIL. Square the first term, this term times this term times 2 minus 2 cosine of x, right? And then you square the last term plus cosine squared x. Okay, so no more radical equations, no more radicals, no more plus or minuses. Multiply both sides by 2. And you're going to have everything now in terms of cosine of x. Move these terms over. If I move this cosine x over, if I add positive cosine x, I'm going to get minus 3 cosine of x. And then, of course, 2 minus 1 is just 1. Okay, so you have a nice and factorable quadratic. You can factor this without much difficulty. This should be cosine of x minus plus is minus 1 minus 1. Cosine of x is equal to 1/2, or cosine of x is equal to 1. So on this problem, right, they want us to just find the solution at interval from 0 to 2 pi. For positive x, for an angle whose x value is 1/2 is going to be at pi over 3 radians, right? And in quadrant number 4, 5 pi over 3. And then for this one, right, where is x equal to positive 1, you're going to have x is equal to 0 radians, right? Of course, 2 pi radians would work, but it does not fall in the interval of 2 pi, non-inclusive. Okay, so you're going to have 4 problems in your homework where you're asked to solve the equation, and you're just going to have to substitute a half angle formula and then perhaps squaring both sides of the equation after you move one of the terms over. Okay, so moving on to the very last problem here. You thought you were done with verifying trig identities, but there's more trig identities now that you know double angle, half angle, and also your cosine, sine, and tangent sum formulas. Okay, so this is an example where you're going to have to go back and use your sum formula. So I'm going to manipulate the left side of this problem here. I didn't really derive the cosine and sine sum formulas with you. or sorry, I didn't derive the double angle formulas with you. And this is where it's kind of useful. So if I'm going to manipulate the left side right here, right? Cosine of 3 theta is the same thing as cosine of 2 theta plus theta. Okay, so hopefully you can kind of see, right? 2 theta plus theta will give you cosine of 3 theta, right? And now, if you recall, right, the cosine of A plus B, right? I cosine the first angle, cosine the second angle, right? And then it's going to be a minus sign here in the middle, right? Minus sine A, sine of the first angle, sine of the second angle. Okay, so I'm going to apply that to over here. So let's apply that. So I take the cosine of the first angle, so cosine of 2 theta, cosine of the second angle, cosine of theta, and then minus sine of the first angle, sine of 2 theta, and then sine of the second angle, sine of theta, all over cosine theta. Okay, so again, I'm trying to get this side to look like this, right? And so notice the right side of the equation has sine only. And so what that means is I'm going to have to transform everything in terms of sine if possible. Okay. Okay, so cosine of 2 theta, right? Remember there's 3 different forms. And the form that I want to use, right, is obviously going to be the one that has sine in it. So I'm going to use the 1 minus 2 sine squared theta for this one. So I'm going to write it over here. 1 minus 2 sine squared theta, right, is equal to cosine of 2 theta. I'm going to keep this cosine theta over here. Now notice everything's already in terms of sine in this problem right here. But somehow I want to get rid of this cosine theta, right? And right now I can't just cancel it out unless I'm able to factor out a cosine theta in this term and this term. So actually I'm going to use my double angle for sine, and I'm just going to expand it. So sine of 2 theta is 2 sine theta cosine theta. Oops. Cosine theta times sine theta. Okay, so all I did was expand my double angle for sine of 2 theta over here. Okay, now take a look. All right, I know it's going to get a little messy, or looks a little messy. Notice there's a cosine theta over here. Notice there's a cosine theta over here, right? You can actually factor that out. And when I factor that out, right, sine theta times sine theta is a sine squared theta. And these cosine thetas are now, you can cancel it out, right, because it's written as a factor. If I combine like terms, right, I'm going to just get 1 minus 4 sine squared theta, which is, equal to the right side of the equation, which we had here in the beginning. Okay, so sometimes, I don't want to write equal sign over here. Sometimes it's useful to rewrite, when you have something that's more than a double angle, rewrite it in terms of a sum, and then you're going to have to use your cosine, sine, or tangent sum formula. Okay, so these problems do get elaborate. You're just going to have to get a little creative with it, but this is definitely a technique that you can use to verify the identity. Okay, last problem right here. Notice this is a half angle formula, right, for secant, and nowhere in the notes have we arrived at a half angle formula for secant. And so if your intuition tells you that rewrite secant in terms of cosine, then you're probably correct. Okay, so what I want to do on this problem is manipulate the left side of the equation and then see if I can get it to the right side. Okay, so secant of theta over 2, right, is the same thing as 1 over cosine of theta over 2. And let's plug in our half angle formula, which is 1 over plus or minus the square root for the cosine half angle formula, right? It's going to be 1 plus cosine of theta over 2. Okay, so right now this looks like it's pretty messy, right? But when you do 1 over some kind of radical in here, right, it basically just gets flipped. Okay, so if you're not quite sure why that is, right, if I rewrite it like this, plus or minus, if I split up the radical, 1 plus cosine of theta, remember you can use your radical rule, right, split up the numerator and the denominator, right, 1 over this just gets flipped, so it actually becomes root 2, right, over the square root of 1 plus cosine theta, which is just the same thing as plus or minus root 2 over 1 plus cosine theta, okay, as a single radical, right? I went from splitting it up back to this. Okay, so 1 over this just ends up being this. Okay, now, take a look. I have this expression, right? I wanted to turn it into this. And really, this is the part where you just kind of have to look at the left side, like, how do I transform this side into this? Well, I'm almost there, right? I already have a 2 over here, so I just need to make this into a tangent. And to make that into a tangent, right, why don't I just multiply everything by tangent? But, you know, if you multiply everything by tangent over here, you're not quite sure what to do with this. So let me just multiply everything by sine theta and cosine theta on top and bottom, okay? So multiply sine theta, cosine theta on top and bottom. Okay, so this times this, right? Clearly, it's just going to be 2 times sine theta cosine theta, which is just tangent theta. This times this is just 1, or sorry, sine theta cosine theta times 1. If I distribute, I'm just going to get tangent of theta again. Right, and then lastly, this times this, notice the cosine thetas are going to cancel out. You're just going to get sine theta. And that will complete the verification for this particular identity. Okay, so you're going to spend a little bit of time on verifying those identities. Make sure you know how to manipulate, substitute, various forms of, half angle formulas, and realizing that secant is 1 over cosine. This one you had to use double angle formulas in addition to the sum formula that you learned, which you might have to go back and review. Okay, so this is not going to be an easy section with your homework, but you're going to have to spend a little bit of extra time, reviewing old concepts, and that will conclude this lesson.